3A.8 Part B, tangent function transformations. So previously we were talking about just our stretching and compression and our phase shift. Now we're going to elaborate with horizontal and vertical translations. So graphing a shift tangent, we're still going to be looking at y equals a. We're going to be looking at y equals a tan bx plus c. And I want you guys to think about this not as bx plus c because you actually are going to have to separate it a little bit. Look at it in this format as far as separating our b and our c to understand the transformations that are taking place. So up first, we're going to graph this transformation. We have 2 tan x minus 1. So 2 tan x minus 1, this right here is our d value. So we know that d equals negative 1. Okay, so with d equaling negative 1, that's going to cause our midline of our tangent function to move down from 0 to negative 1. So our parent function starts at 0. Now it's going to move down to negative 1. So now we're at negative 1. Other than that, we're going to also take into account our period. So we're at 2. So with our period, it's still going to be pi, but our y values are what's changing. So remember, your a affects your y value. Like, how is it impacting your y values? Previously, our y values were at, our a is 1, which meant that we were only 1 unit from our midline. Now we're going to be 2 units from our midline because that's our a, our amplitude. Now, we did not go left or right. So our asymptotes are still in place at negative pi over 2 and positive pi over 2 and all of their quote-unquote odd multiples. Okay, so now we're here. So our points, so we still have our key points. Remember, it's asymptote, then we have our low, then our intercept, then our high, then our asymptote. So still keeping that in mind. We are now going to, at negative 1, go to our low. Our low is now 2 units down from our midline. And our high is now 2 units up from our midline. And our midline is now here. Not quite sure why it keeps deleting, but we're going to pretend that it's not. So when I graph it, it's going to... that was horrible, guys. Per usual. Me trying to draw. Okay, I think I did fairly decent there. And then the pattern would continue. So here again, we have a low, intercept, low, asymptote, low, intercept, high, asymptote. So again, it's doing... I know you hear yourselves in the background. Okay. And so here we go. Asymptote, oh my gosh. Asymptote, low, low, intercept, high. And again. Okay? All right. So that's the impact that our D is having on us. Now we're going to talk about our half. So we're at 3, 10, 1 half x. Okay? Oh, sorry, I didn't state our period and show all of our asymptotes. So our period here is still 1 pi because it's from negative pi over 2 to pi over 2. So our period is still going to be 1 pi. Our asymptote is still at our multiples of our asymptote. It's still going to be at x equals pi over 2 plus or minus, because either you're going left or right, pi times k, and k is an integer. Okay, now we're going to do it on this one. So on this graph, we are going to be looking at our halves. And so we now have b is a half. So same thing we talked about with our period. This is affecting our period now. And so in our last set of notes, we talked about identifying the period by thinking about it in terms of left and right. Like, how is your period changing left and right? So if we now have negative pi, so for my left, I'm going to do it up here. So on my left, I am normally at pi, right? And now we're at x over 2 equals negative pi over 2 is where we're normally at. So that puts me at, when I cross multiply and divide, I get that I'm now at negative pi, right? So from the left side, my asymptote is now going to be at negative pi. Okay, the right is the exact same thing, but instead of being negative, it is positive, which means that now I'm going to be at positive pi. So based on this, I can now establish that my period equals now, it's not just 1 pi, it is now 2 pi long, right? And I'm going to find my halfway point. And my halfway point is at 0 still. My D is because that's D equals 0. So my midline is still at 0. And my A is telling me how far my high and my low are from my midline, okay? So now our A, my low, I'm going to find my halfways. So here's halfway is going to be still at 0. And then halfway between halfway is here. And it's going to put me down here at negative 3. And then my other halfway point is at, this is negative pi over 2. This is positive pi over 2. And my high is going to be at positive 3. And so my graph looks like, I swear, I'll be trying, y'all. That did not come out very smoothly. Let's try that bad boy again. So we're going to go here, and let's see if I can graph a little bit better than that. I don't know why it still appears that I'm drawing straight lines. I promise y'all I am not trying to draw a straight line. It just is out to get me. Maybe if I do it in sections. That got real bad real quick. Also, this computer and its writing thingy is very sensitive, so we're gonna go.
Only way to be happy.
Okay. That was a little better.
Yeah.
We're gonna go with that. And then the pattern will repeat again on the outside. So asymptote, low, intercept, high, asymptote. So we're now asymptote, and we're going to be at our low, which would be here at 3 pi over 2. And then keep going to our intercept, which would be here at 2 pi. And that will be on that side. And then on the other side, again, this time it's going to be high, then intercept. So our high is at negative 3 pi over 2, 3. And then our intercept. So drawing, again, me and my lack of drawing abilities, gonna do my best. Yep, that's what we're gonna call that. We're gonna trust that as what it is. And then we're gonna do the next one. And we're gonna trust that. Look at the graphs, look at it better. So now your asymptote. So when I'm describing my asymptotes, what is the pattern that I see? My asymptotes are at all of my pi values, right? So we're at pi plus, we're at pi, and the next one, not at 2 pi, but at my odd pi's, right? So pi plus 2 pi times k, and again, k is an integer, all right? And there we go.
All right, so we left off here. By I mean me. As you can tell, I started feeling my sinuses started getting the worst of me. So sorry for the weird sounding voice. It sounds weird to me too. But here we are. We're on transformations of tangents, and we're going to start off with negative 2 tan x plus pi over 2. So very similar process as sine and cosine. We're going to acknowledge what our A, our B, our C, and our D are. So for this, our A is 2. The negative is just telling us that it's reflective, right? So instead of it will have our asymptote. Instead of having our low, though, we'll have our high, then our intercept, then our low, then our asymptote, right? That's what that's telling us. So we'll have that. And then the 2 is telling us now our distance from our high to our intercept. But our high to our mid or our intercept is going to be 2. away. And then x plus pi over 2. Remember, this is a liar. So this is not what's really happening. So think about this as it's a liar. So we're shifting it to the left pi over 2. Okay, so we're shifting everything to the left pi over 2. Remember, our parent function normally is at negative pi over 2. So now we have an asymptote at pi over 2. Okay, there's no b, so our period is still going to equal 1 pi. So from negative pi to 0 is 1 cycle. Okay, so we have asymptote, and now we have our high. Our high is going to be at 2 because our a is 2. We have our intercept at our halfway point, and our low is going to be at negative 2 because our a is 2. Okay, so our pattern is, if you wanted to continue, asymptote, high, intercept, low, asymptote, high, intercept, low, asymptote, right? Asymptote, high, intercept, low, and then following, it'll be backwards though, because I'm reading it backwards, right to left. So asymptote, then low, intercept, then high. So bear with me as I do my best to draw out my curves. And we're gonna have, okay, that one just kind of came out looking like a straight line. Let's try again. Don't be a quitter. That one didn't even make it through all the points. I think you're getting the gist of this curve. Remember, it's not my strongest thing of drawing in life. But there's the gist of it. So we have our graph, and it says we're going to state our period and all of our asymptotes. Well, our asymptotes now, we're going to establish the pattern of where do our asymptotes happen at. So our asymptotes are at x equals, and this time it's at all of our odd values of pi, right? So it's at, notice we're at negative 1 pi, 0, positive 1 pi. Well, I guess it's just all pi values, technically, yeah. So we just keep going to pi's. Yeah, 1 pi, 2 pi, 3 pi. So we would write that as pi, because it goes left or right, plus or minus pi times k. Okay? And again, k is an integer. Alright, over here, we have 3 tan 2x minus pi plus 2. So the first thing that I want you to acknowledge is that this 2x minus pi, this doesn't really tell us our c value. So keep that in mind, that that is not our actual c value. So we're going to factor that out. So when we factor it out, this is actually parentheses 2, parentheses x minus pi divided by 2. Okay, that's what this really is. Okay, so now we see our B, our C, our D, our A, and each one has a role. Okay, the first one we're going to start off with is our D, because our D is going to tell us our midline. So our midline, where we're going to intersect, right, is going to be at 2. So we're moving from 0 and we're moving up to 2. So I'm going to just kind of sketch it in. It's kind of bad that I'm doing dashed lines for the midline because that represents asymptotes also too. But you get what I'm saying. I'll switch colors for my asymptote. Excuse me. Next is our asymptotes. So our asymptotes are, we're now at moving pi and a half units to the right. So we're going to the right pi and a half units. So if I'm moving to the right pi and a half units, I'm going to be at 0. Okay, so we know what our a is going to do to our function. So our a is going to affect our high and our low. Our b we talked about in 3A.8 part A, and we're going to do our b first so that we can figure out our asymptote. But to find our new asymptote place, we're going to be using our B and our A. Okay, so we talked about finding our asymptote. I encourage you to do the method of your left is setting up your proportions. So we know that our left asymptote is always at negative pi over 2. Well, our B is 2x. So our B is 2x over 1. So when we cross multiply and divide, we're going to be left with negative pi equals 4x, right? So therefore, x equals negative pi over 4. Now, this would be our new left asymptote if we didn't have that phase shift. We have that phase shift that tells us that we need to move our asymptote right pi over 2. So we need to move our asymptote right to the right and go from there. So we're moving our asymptote to the right pi over 2. So next, after we do that, we're going to have to do negative pi over 4 plus pi over 2. Okay, so when we do this, you can do a quick multiply. You can multiply. I'm going to multiply by 2. So I'm going to multiply the numerator and denominator by 2 so that this can become a 4, and now my denominators are the same. So you have negative pi plus 2 pi, which gives us negative pi plus 2 pi gives us positive pi over 4. So now our asymptote is going to start at pi over 4. So our asymptote is now here at pi over 4. Next, we're going to need to figure out what is our period. So our period equals pi divided by our b, right? So for this problem, it's going to be pi divided by 2. So our period is pi over 2. So we're going to go half of a pi from here to here, right? So if I'm at pi over 4 plus pi over 2 is going to put me at where? If you said 3 pi over 4, you're correct. Think about it as a quarter plus 50 cents gives you 75 cents. So your asymptote is now right here. Okay, so now you can see that your asymptotes are happening every odd quarter, right? Every odd quarter. So we have our asymptotes are taking place at x equals, and it's at our I can't even talk, our quarter mark. So at pi over 4 plus or minus a half. So plus pi over 4 plus or minus pi over 2 times k. And again, k is a integer. And k is an integer. Okay, so I'm going to finish out my graph. I'm going to put the rest of my asymptotes. So I have asymptotes at 1/4 pi, 3/4 pi, 5/4 pi, 7/4 pi, 9/4 pi. On the other side, I have asymptotes going the other way at negative 1/4 pi, at negative 3/4 pi, negative 5 pi, negative 7 pi. So when I said odd quarters, I hope that now makes sense to you. So when I'm here, my halfway point, I'm going to identify my halfway point. Whether it's looking at this interval or that interval, I'm just identifying my halfway point. So my halfway point on here is going to be at 0. That's going to be my intercept with my midline. And it wasn't negative, so I'm going to start off with my low. My low is going to be 2 units down. So I'm at 2, so my low is going to fall right here on the x-axis. And my high is going to fall up here on Okay, half of a quarter is 1/8. And so this is at positive 1/8 and negative 1/8. And then it's going to graph like so. Okay, and we all know that I struggle drawing these, so I'm not going to draw very many of them. I'm just going to draw 2 more and call it a day. So I'm here. I'm going to be here. I'm going to go up to. And again, here. Curve on through. Okay. Same thing over here. I'm going to be on the x-axis. I'm going to be on the intercept. And I'm going to be up here on 2. And we're going to curve on through. Okay. So there is my tangent. I don't know why it took me so long to draw the tangent graph, but there it is. All right. Next, here we have y equals 3 tan x divided by 4 minus 2. Find the following. So we're going to find our left asymptote and our right asymptote. So to find our left asymptote, remember we're looking at what is our parent function asymptote originally at? Our parent function asymptote is originally at negative pi over 2. Now, according to what is our argument here? Our argument is that x over 4. So we cross multiply and divide, and we get negative 4 pi equals 2x. When we solve for x, we end up getting x equals negative 2 pi. So our left asymptote is going to be at negative 2 pi. Our right asymptote of our parent function starts at positive pi over 2. And we're going to set that equal to x over 4. Again, when we cross multiply, we get 4 pi equals 2x. So our asymptote is going to be at x equals positive 2 pi. Bam, 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 we're geniuses. Okay? Our period. Remember, your period is your p equals pi divided by your b. In this case, our b is 1/4. So it's going to be pi divided by 1/4, which equals, keep, change, flip. So we end up with 4 pi. Okay? So if I'm describing this, this would be a horizontal dilation. Horizontal dilation. Factor of 4. Factor by 4. Must be pi of 4. By 4. Of, by, I'm not sure. Of 4. Okay, so the transformations that we have left to describe. We still have to describe what is our A effect and what does our D effect. Okay, those are both vertical transformations. So your A equals 3 is going to be your vertical dilation. By 3. And your D equals negative 2 is going to be your vertical translation. I'm just going to write it down. 2. All right, it's asking us for intervals where the function is concave down. Okay, so when we're thinking about this, we're thinking about the shape of it. So probably should just draw it. So what we know now. So we know that our graph, it's going to start at negative 2 pi. So we're going to start at negative 2 pi. I'm going to just label it out here. You are now negative 2 pi. And we end at positive 2 pi. Trying to be as symmetrical as possible. I think I did pretty good. Positive 2 pi. Our halfway point is going to be at 0. But we have a vertical dilation. So our midline is going to be at 2. So we're going to let this be our midline, or another invisible line. So we're going to be here at 0, 2. Okay? So halfway between here is going to be negative pi. And halfway between here is going to be positive pi. That is not a negative a, a positive a, so we're still going to go asymptote, and then we're going to go low. So we're going to go 2 units down from here, which is going to put us at 4. So we're at 2. It's going to put us at 4. So 2 units down for our low. It's going to be at 4. Is it 2? Oh, it's 3. I can count. A minute, I can read. It says 3 units down. No one was here to correct me. It's okay. We're going to go 3 units down. So 1, 2, 3 units down. This is not drawn to scale, obviously. We're going to be here at pi negative 3, negative 5. So we're at pi negative 5. Then we're at 0, negative 2. Then we're going to be 3 units for our high. So currently we're at 2. So 2 plus 3, negative 2 plus 3 puts us at positive 1. So we're going to be here at positive 1. I have to cover up my pi symbol. And our graph is looking something like that actually isn't that bad for me. I'll take it. All right. It's asking for our POI. Where is our concave down? So we're concave down from here, from negative 2 pi up until 0. And that's when we change our rate. So we're concave down from negative 2 pi up until 0. Or you can write it as an inequality, negative 2 pi less than or equal to 0. Okay, and because that's where we're located, for what we see in our graph, our point of excuse me, on the interval that we see, we're concaved up from 0 to 2 pi. Sorry, 0 to 2 pi. Or you can write it 0 is less than or equal to x, which is less than 2 pi. Okay, can't be equal to an asymptote. All right, and then it says, where are the points of inflection? Well, your points of inflection is where does the concavity change? And our concavity occurs at 0, negative 2. Okay, now, this is just for this graph. So our POI for this graph is 0, negative 2. All right, however, there are other POIs because this is a repeating graph, right? So if it was to ask you for the rest of them, it would be at where I can't even write the at symbol. I don't know why. It would be at where the next one would be. So if my period is 4 pi, then my next one would take place at 4 pi later. Does that make sense? So every 4 pi is where it's going to happen. So every interval, there's no point in writing 0 plus 4 pi. So it would be every 4 pi k is where I would have at x, well, x equals. At x equals 4 pi k, that's when y would equal negative 2. And that's where the rest of my POIs will lie, if it was asking for the entire graph. All right? Next, it says y equals negative 2 tan 1 half x plus pi plus 1. Find the following. Okay? I would like for you to pause and try to do it all from beginning to end. But again, you want to make sure you identify your asymptotes. As long as you do your left and identify your period, you don't really need to do the right, but just to make sure you're comfortable doing both is ideal. Okay? Now, we haven't did it where our entire argument, so I'm going to show you how to do it without the period. because on the last example we did it with the period. But to do it without the period, you're going to use the entire argument with inside your trig function. So it's going to be our normal left side is at negative pi over 2. But now it's going to be equal to, and you're going to take everything that is inside parentheses goes in the numerator. So it's going to be x plus pi divided by 2. And you're going to cross multiply and divide that. So we cross multiply and we get negative 2 pi equals 2x plus 2 pi. Okay, and our job here is to get x by itself. So we're going to subtract 2 pi and divide by 2. Hopefully we all see that. To get x by itself, we're going to subtract 2 pi and we'll divide by 2. When we subtract 2 pi, we're left with negative 4 pi excuse me, equals 2x. And then we divide by 2 and we get our x. So we know that x equals negative 2 pi. Okay, you can do the same thing to find the right asymptote, but once you have x equals negative 2 pi and you identify your period, you can just add to find that. Okay, so let's do it this way. So your period again is period equals pi divided by your b. So our pi divided by b is 1/2 equals 2 pi. So you know your period is 2 pi. So if your left starts at negative 2 pi, that means you're going to go another 2 pi in order to find your right. And so therefore your right asymptote is going to be at 0, at x equals 0. Okay? So that's how you can do that. But when you have multiples, instead of doing it in the 2 parts that we did, you can do it all at once and get her done. Okay? Just remember, if it's written as a fraction, whatever's in parentheses, that's a whole number, it goes in the numerator, and then you just cross multiply and get your x by itself. Okay, so continuing what we have, we now know where we start. We are going to start at negative 2 pi, and we're going to end at 0. So first asymptote is at negative 2 pi. Second asymptote is at 0. Okay, so therefore our halfway is going to be at negative pi. And then our quarter marks are going to be at negative pi 3/2 and negative pi halves. So we're at negative 3 pi halves here. Well, that's not what the point is, but I'm saying at here. And then we're here at negative pi over 2. Okay? All right, and then we'll continue on the other side, same pattern, right? Transformations. So describing your transformations that took place. So all transformations that took place, we have a reflection because it's negative. So we have a reflection over x-axis. Okay, moving on to the 2, we have a vertical stretch by 2. Vertical or dilation by 2, I'm sorry. Okay, moving on to the half, we have a horizontal dilation. Remember, our x's are liars. So even though it looks like it's multiplied by half, it's actually doubled. So we have a horizontal dilation by 2, by a factor of 2. And then last but not, well, we're not last. Then we have pi. So we have a horizontal translation. So moving on to this guy. I'm pretty sure I did not leave y'all enough room because I don't have enough room. Horizontal translation. And we're going to be going left because x's are liars. Pi. And then we have a vertical dilation, which is our very last guy. So we have a vertical translation. We're going to be going vertical, and it's going to cause us to go up 1. Okay, so graphing what we know. We already have our asymptotes. We now know that our midline is now at 1 because our D is positive 1. So our midline is now at 1. So pi is our halfway point, not our intercept. There we go. So we know that we're going to intercept our midline at negative pi, comma 1. And because it's negative, the reflection lets us know instead of being asymptote low, intercept high, asymptote, we're going to be asymptote high, and we're going to need to go 2 units above our midline according to our A. So instead of being at 1, we're going to be up here at 3. So we're going to go up to 3, up to 3, and then we have our intercept of our midline. Then we are going to go here. So we're at 1. 1 minus 3 is going to put us down here at negative. We're at 1, right? Yeah, 1 minus 3. I had a brain fart there. It puts us at negative 2. I don't know why. I think because I drew this not like drawn to scale and it threw me off. Like, why is that so far away? But it's me, and that's why, because I'm a horrible artist of drawing. And then we're going to do our very best to go down. Pretend that is a sexy curve for you. All right, intervals. So now looking for, see, I need to like, I'm gonna make this curve. It's gonna bother me. It's just embarrassing at this point that I can't draw a curve. I'm not sure if that's worse or better. We're gonna go with it. I need you to see the points of concavity, and you could not. So we're concave down from negative pi to 0. And we are concaved up from negative 2 pi up. Nope, nope. You see nothing. It's an asymptote, negative 2 pi to negative pi. Okay? And our point of inflection, when does this change, is at negative pi 1. Negative pi, comma 1. Now, where does this happen at all over the place? Well, it also occurs at what? We're going to go negative pi plus 2 pi, because that's our period. So negative pi plus or minus 2 pi repeatedly. Yeah. So from where we're at would be negative pi plus or minus 2 pi times k. And again, k is an integer. Okay? K is an integer. And at these values, this is when y will also equal 1, which will be your POI. I'm going very slow with these drawings. All right, I would like for you to pause for a moment and see if you can identify the graphs by working backwards. So you're given the graphs, and you're going to work backwards, identify your A, figure out your period, and identify where your isotopes are so that you can know which one is matching. All right, welcome back, and thank you for pausing because you are great and you listened. So up first, we're going to look at graph number 1. Graph number 1, we're going to identify our A. So our A, D is still at our 0, is at our x-axis. So our A, how far are we from our midline, is only 1 unit. So we know that A has to equal 1. Well, that eliminates A and D pretty quickly. Then next is what are we doing? So our pattern here, we have asymptote, and then we have low, intercept, high, asymptote. So that means that our A is positive, and because our A is positive, we know that it cannot be B. So we already eliminated A and D, It cannot be B, so it has to be C. And that's just from looking at our A. So we know that it has to be function number C. So from there, we can double check and make sure everything else adds up. We know that there's no horizontal dilation, but there is a phase shift, and our phase shift causes us to shift to the left pi over 2. So it used to be at negative pi and a half. Now it's at negative pi. That checks out. That's because our phase shift, which is your C, right, says that we went left pi over 2. Okay? And then our period is still pi because we didn't have I don't know why I'm having a break part, a B value, a horizontal dilation value. So, yeah. All right, let's look at number 2. Number 2, to start off with, we're going to identify our midline. So finding our midline. Our midline is still at 0, as you can see. Okay, so that means that A has to be 1 or negative 1. So when we look, we see that our A has to be 1. Wait, where's the 2? Our A is 2. Sorry, I see it now. I was like, what happened here? Our A is not 1. Our A is at 2. Our A is at 2. But our A has to be positive. So our A is positive. And that's because, again, it's asymptote. Then our low, I can't really tell if the midline, yeah, it doesn't look like it moved. Yeah. Halfway, halfway, halfway. Okay. Yeah, I'm on the right spots. I'm like, these lines are playing tricks with my eyes, guys. So we know A equals 2. We know that our D has to be 0 because there's nothing going up and down. And then from that alone, we know that it has to be A. So this has to be graph number letter A. Just double checking everything. We're going to look at our pi over 2. So we have 2 is our B. So we're looking at our asymptotes, making sure that that is correct. So normally our asymptotes are negative pi over 2, right? Negative pi over 2. However, our argument is 2x over 1. So our argument is 2x over 1, which puts us at negative pi equals 4x. So now we're going to be, asymptotes are going to start at negative pi over 4 is x. Okay? Do we have an asymptote at negative pi over 4? Yes. Our period is now a half because our period now equals pi divided by 2 because our b is 2. And do we go a half? So we go from negative pi over 4, excuse me, to positive pi over 4, which means that we did go half of a pi. Okay, so it checks out. Now, down here, obviously all you have are negative lefts. You just now have to decide whether it's a negative 1 or a negative 2 and if there is a D. So we know our A equals a negative because we start off as a high, then we go as a low, so it's a negative. I know it's not a line, but how that helps remember is think of like increasing and decreasing of a linear. And so that just helps me. But A equals negative, and now we're going to determine our D and our A. So our D, our midline. Our midline is now at -2. So that means that D equals -2. From our midline, our halfway, from our midline, our high point seems to be at 1. Like it's, yep. Guys, what did I just do? It's not at 1. Our midline. Does that not look like a -2 to y'all? I'm going to stick with -2. And it looks like this is at 1. Yeah, I'm not crazy. I mean, I may be a little bit. But as you can see, all of them are at 1. So we know that D equals -2 and A is going to be -1 because your amp here is 1. So just based on those two pieces of information, we know that it has to be B. So this graph has to be B, and we're going to check to make sure everything else is still true. Because your B value here is still 1, you know that your period equals 1 pi. So from -pi/2 to +pi/2 still is in effect for our asymptotes. Boom, boom, boom. Period is checked. Yeah, that's all we really needed to check. By default, you should have ended up with this one being D, but we're going to talk about and check that it is D. So first off is our midline. So our A. A has to be negative, okay? So A has to be negative, and then we're going to find our midline. Our midline is at 1, it appears. So we're now at 1. So we know D equals +1. From there, our A, so from our midline to our high, according to who our asymptotes are, it looks like our asymptotes here, and this is here, yep. So we have asymptote. It's a pretty close asymptote. I don't think it's right there, Shauna. I think it's at pi. I put it too close. It's meant to be at pi. We're going to be pi, and this is approaching -pi. Yeah, there we go. So our asymptotes are at -pi and pi. And our halfway between 0 is at pi/2. And at pi/2, we are down here at -1. At -pi/2, we're up here at 3. So we're 2 units away from our midline, which means that our A is -2. So we have A equals -2, D equals 1. Check. Next, you're going to verify, you can check your period. Your period equals pi divided by your B, which is 1/2, which gives us 2 pi. And we are 1 pi here, 1 pi here, 2 pi is in effect. And then lastly, verifying that your asymptotes are where they need to be. Remember, originally we're at -pi/2, and it's going to equal x/2. That's going to give us -2 pi x divided by 2, which leads us to x equals -pi. Did we start at -pi? We do. We're geniuses. We did so great. All right. Lastly, working backwards. So I would like for you to do this one completely, working backwards, tying everything together, and then writing out the equation after you've identified your A, your B, your C, and your D. Pause and then check back for the answer. Okay, thank you for pausing. Let's see how we did. So from here, you would identify your D and your A. So your D, your halfway, it's probably the easiest thing to identify here, is at 2. So we know D equals 2. Next, we know our A. Your A is positive. So looking at from your asymptotes, where is it at? So here is my my asymptote. Here's an asymptote. Right? Do we see the asymptotes? So halfway points would be at pi and negative pi over 2. And they don't go quite far away. They're only at a half. So your A should have been at a half. So you have A is a half. Next is your period. So how long is it from one asymptote to the next asymptote? If you want to think about it in halves, so each one of these is a quarter of a mark. So this is 1/4, 2/4, 3/4, 4/4 of a pi, which means that your period is pi. Your phase shift is how much did it move left or right. Well, normally we are at negative pi over 2. And now we're at negative pi over 4. So that means that we had to shift right. So we had to go right. And we went right how much? Well, we went right approximately pi over 4 units. Okay, when you determine your phase shift, you want to look at your cycle that's closest to the y-axis to determine the phase shift. You don't want to go to the cycle that is the furthest away. You want to go to the cycle that is the closest to the y-axis. So this is the one that is closest to the y-axis. So this is the one I'm going to analyze. How did it shift? Okay. Next, our points of inflection. Our points of inflection are where we are transitioning on our midline. So this guy is a point of inflection. This guy is a point of inflection. And this one here. So the points of inflection that you can identify from here are going to be at negative 3 pi over 4, comma 2. Next one's going to be at pi over 4, comma 2. And last but not least is going to be at 3 pi over 4. Is it 3 pi? No, 5 pi over 4. I did not mean to say that. 5 pi over 4, comma 2. And now we can write our equation. So our equation is y equals, our A is 1/2 tan. We don't have a B, but we do have a right. So x minus pi over 4 plus 2. And there you go. Thank you for watching.